All right, so this is the lesson on spheres. I'm not going to get into the deep parts of the surface area and the volume. If you're interested in where those formulas came from, I think I might try and show a short little YouTube video, but your book also kind of shows where they come from. Okay, so here are your formulas. The area is 4 pi r squared, and the volume is 4/3 pi r cubed. So you can kind of see r squared a little bit, and the 4/3 kind of like a 1/3, but a little different too. So these are the formulas that you need. In the first part, find the area and the volume of a sphere with radius 2. So there's your formula for area, and there's your formula for volume. So just plug in the number 2 and evaluate. So you can push pause and do that now. Okay, when you have done that, I would think this one would be pretty easy. Please remember you're squaring only the radius, you're not squaring the 4. So 2 squared is 4, 4 times 4 is 16. Okay, in the volume, I cubed the 2. 2 cubed is 8. 8 times 4 is 32. So that's where that's coming from, that 32 pi. And then all of that over 3. So the next one, the area of a sphere is 256 pi. Find the volume. Okay, well first this is my formula for the area of a sphere. Again, you are welcome to push pause, solve the problem, and then come back to check and see if you're right. Okay, what I did next is I just plugged in the 256 pi for the area, and then I solved. Okay, I divided both sides by 4 pi. That got me 64 equals r squared, and therefore radius must equal 8. Now be careful. You need to answer the question which said find the volume. So I'm going to take that radius of 8, and I'm going to plug that back into the volume, which you'll see here. The 2048, again, is coming from 8 to the 3rd, and then I multiplied that by 4. That's where 2048, the pi, and then all of that was over 3. And again, I go really fast. Feel free to pause, write questions in your notes if you're not sure how to do something. Okay, for this one, it's a table, as you can see. D is diameter, R is radius, A is area, V is volume, all of a sphere. So what I'd like you to do is push pause and work through the table. When you get down here, compare the areas of the last 2 problems in the table. You're going to go here. You're going to compare what you got here, kind of like a ratio, and see what it reduces to. How does it compare? And then do the same in the volume. You're comparing 2 numbers. Okay, so push pause, do that, and then come back. All right, so here I have the answers for your table. This is a lot to look at, so you may want to push pause and go through and check your answers. I tried to show all my work, so if you need help, let me know. Okay. Then down here is where I talked about, I compared the areas. The first was 4 pi r squared. This one, remember when you're squaring 2r, it's 2r times 2r, so it's 4r squared multiplied by another 4. That's where that 16 came from. When I reduce that, I divide both sides by 4 pi r squared. I get a 1 to 4. So when I doubled the radius, the areas was a 1 to 4. And that's probably not too surprising to you. If they had a 1 to 2 scale factor, they have a 1 to 4 ratio of areas. In the volumes, I did the same thing. What you'll see from here to here is I multiplied both sides by 3 to clear out the fraction, divided both sides by 4 pi r cubed, and I got a 1 to 8. And you're going to see that come up tomorrow, or Friday, I should say. All right, for the next one, a plane passes 4 centimeters from the center of a sphere with radius 7. Find the area of the circle of intersection. We did ones like this before in, I think it was the trig unit. First, let me give you the picture. So here's my sphere, and imagine the tennis ball, and you cut it off with the saw. You cut the top of the tennis ball off, so it has a flat side. And there's this dotted circle here. That's kind of, if you're looking at the top of the tennis ball, you'll see a circle. So the distance from the center is 4. See how I have that labeled? The radius is 7, and I chose to draw the radius here so that I would make a right triangle. So I have the 4, I have the 7, and then I have the radius of this dotted circle. So the first thing I did was I need that radius. And in this case, I called that x. Because how am I going to find the area of this circle if I don't know the radius? So the first thing I did was I found that radius, which I called x. I used Pythagorean theorem. And then that circle is two-dimensional, okay? It's just a two-dimensional circle, so I used the formula for the area of a circle. And I got the area here. Okay, in the next one, the number of square centimeters in the area of a sphere is the same as the number of cubic centimeters in the volume. So the first thing I did, sorry that's crooked, I'll try and fix that for you, is I set the two equal to each other. Then I multiplied both sides by 3, so I didn't have that fraction. Then I divided both sides by 4 and pi, and that's how I got to here. And then I divided by both sides by r squared, so I got a radius of 3 for the sphere. And you can check that. If you plug that in for the area and you plug that in for the volume, you're going to see you get the same thing. Okay, if the radius of a sphere is halved, the area of the sphere is multiplied by blank and the volume is multiplied by blank. Again, what I would do is try and do all these problems on your own and then come back and hear the answers and check your answers. So for the area, you'll see I did the area the normal way, and then I did it again where I plugged in 1/2 r instead of r. Now remember, when you square a half of r, it's 1/2 times 1/2, which is 1/4. So when I'm half the radius, the area is multiplied by 1/4. I did a similar thing with the volume. Okay. Again, I plugged in just the radius itself, and then I compared that to 1/2 r. That's 1/2 times 1/2 times 1/2. That's what happens when you cube it. That's the 1/8. And so you multiply it by 1/8. And that should be similar to what you saw we did in the table. Okay, surface area of a sphere is 16 pi. Again, try these before you're listening to me. Try them and then come back. So here's my area formula. I said, okay, that equals 16 pi. I divided both sides by 4 pi. I got r squared equals 4, so radius equals 2. Diameter is just double the radius, easy peasy. And then I plugged in 2, that radius, into the volume formula to get this. This question down here is very similar to the one we just did a little while ago. So again, here's your picture. Again, I'm trying to draw the radius here to make the right triangle. And again, I am solving for the radius of that dotted circle, which is x. So this is what I did to get the radius. I used the Pythagorean theorem. So that little x I got is 12. And again, that's a two-dimensional shape, so I just plugged it into the circle formula. That's where that came from. All right, now this one. So it's a sphere inscribed in a cylinder. So it's kind of like a tennis ball in a can, but just one tennis ball. And inscribed would mean its edges, the edges of the sphere touch the edges of this cylinder. Okay, so I kind of drew a picture here. It said a cylinder with diameter 5 and height 5. So that means, because I can see, I could take this, let me move this, and move it up. You can see that 5 of the cylinder is also the diameter of the sphere. So that means the radius of the sphere is 2.5. So I plugged in 2.5 for the radius formula, and I got that for the volume of the sphere. Find the volume of the region outside the sphere but inside the cylinder. So the first thing I did was found the volume of the cylinder. Okay, that's a different formula. Area of the base, right here, times the height. I got this. And I said, okay, if I take that big cylinder area and I subtract the area of the sphere, I should get what I want, which is here. I rounded that. If you have the fractional equivalent, you're in good shape. So again, I'm hoping you didn't just listen. I went really fast. My expectation was that you would try these problems by yourself and then come back and hear an explanation after you've already had a chance to think about it.